In this video, we'll talk about order of operations. So, real quick, let's review. Usually the useful mnemonic for trying to remember order of operations is PEMDAS. And the idea being the P stands for parentheses, the E is for exponents, M is for multiplication, D is for division, A is for addition, and S is for subtraction. And we go left to right. So we start with parentheses, if we have them, and we go all the way over to subtraction. Now there are some caveats. Technically, multiplication, division, doesn't matter which order you do it in between those two, and technically, addition, subtraction, doesn't matter what order you do between those two. There's also a couple of other functions eventually that we'll learn about that don't necessarily fit under the classifications, but they do work their way in some way or another. So before we get into examples, let's talk about some vocabulary. So the difference between simplification and evaluation. So when you're evaluating, you're looking for a single number. So like, for example, 7. So the idea is I'm going to work an expression all the way down until I get to a single number. The difference between evaluation and simplification, if I'm simplifying, that could be where I have variables, usually is where you see it. So if it boils down to x plus 4, well, I can't really combine the x and the 4 because I don't know what x is yet. So this would be a simplified expression. That's as far as I can take it until someone tells me what x is. Once I do that, then sure, I can evaluate that expression. It's just a little bit of difference on the subtlety between evaluation and simplification. So let's practice real quick. Let's evaluate some expressions. So if I'm following my order of operations, I have to ask myself, okay, first, do I have parentheses? I do, right here. So I'm going to do them first. Now, I find it's easiest if you kind of work down with these problems. So I'm going to take 8 plus 2, which is 10. So 3 times 10 minus 5. Okay, I've dealt with the parentheses. Do I have any exponents? No. So move on to the next thing. Do I have multiplication? Yes, right here. So I'm going to take 3 times 10. That would be 30. And then I'll tack on the minus 5. Then I'm going to go and ask myself, okay, do I have division? I do not. Do I have addition? I do not. Subtraction would be my next thing. So I'm going to take 30 minus the 5, which would be 25. This would be our evaluated expression. This is as simple as it gets. So let's take a look at another example. What we're doing here will be slightly different. In this one we have variables, however, they're telling us x is 5 and z is negative 12. So the first thing I'm going to do is I'm going to rewrite this expression with the numbers instead of the variables. So I'm going to write 2 times x, which in this case we know it to be 5. Now, something I always do to keep track of it is I always put it in parentheses myself just in case it's multiplied or divided or taken to a power. Then I know, okay, I have to do that first. In this case, you could probably get away with not putting the parentheses around it, but it's good to do it just in case. And then we'll have minus a negative 12. Now this is one case where the parentheses did really come in handy. It's going to help me keep track of this double negative case. So, again, we're going to go down through our order of operations. Do I have parentheses? I do. Let's do that first. So I'm looking at two kind of spots where we can deal with the parentheses, I guess, in essence. So we're going to do that first. So I'll keep the 2. 4 plus 5 is 9, so I'm going to have 2 times 9. This minus minus is going to turn to a positive. So instead of minus a negative 12, I'm going to have plus 12. Okay? Now I'm going to go to the next one down the list. There's no exponents to worry about, so we're good there. Okay? I do have some multiplication, so let's do that. So it'll be 18 plus 12. Then, no division. We do have addition, though. So this will turn into, it looks to me like 30. And that would be our evaluated expression. This is as good as it gets for the moment.